Welcome everyone to our Designing and Assessing Digital Technologies projects presentation for years 3 and 4 and years 5 and 6, focusing on version 9 of the Australian curriculum. This is the final presentation in our version 9 Australian curriculum series. My name's Dion Scanlon. I'm a senior educator for Grok Academy. I've been teaching in Tasmanian schools for nearly 25 years, mostly in the Catholic system, and I have a long history of working in the digital technologies area. And I'd like to introduce you to Meredith.
Hi, my name's Meredith, and I've been teaching for over 25 years in primary schools. I have experience teaching in high schools also for a few years and in background in adult education. Today we're going to be looking at curriculum and planning and some of the new features of Australian curriculum. We'll be looking at an example project which will follow the theme all the way through the presentation as a rich task that could be linked to multiple curriculum areas. We'll also have some further project ideas, and at the end we'll wrap up with some resources and ways that you can contact us if you would like more information. The goals for this workshop will be to consider the links to the Australian curriculum version 9 in digital technologies and projects with digital solutions. We'll also be providing some examples on how to implement the various sub-strands of digital technologies with integrated projects, and we'll be looking at ideas for assessment in relevant subject and achievement standards. We've seen this slide in previous episodes, but it's very valuable, so we're going to revisit it. How do we know what to teach? We look at the content descriptions. The content descriptions will give you an explicit statements of what has to be taught, and also we'll need to think about how to teach it. So when we're thinking about that, we look at the elaborations. They're optional, but a great place to start if you don't know how to begin. And finally, how will you know when they've learnt what you're teaching? Well, you refer to the achievement standards. We use the achievement standards to then determine what needs to actually be assessed. You should also provide multiple opportunities for students to demonstrate their success in the space that you're assessing, and you might use various forms of assessment, which we will talk about later in the presentation.
We're now going to have a quick discussion about the basic curriculum outline for working through projects, but we're going to start having a look at the concepts that are involved in the technologies curriculum and the digital technologies curriculum specifically. There's some really key concepts that this will focus on, and you can really dig deep into those kinds of things. So looking at the digital technologies concepts, thinking about the ones in the right-hand column there, specification, for example, where you're actually starting to look at defining problems is a really important concept when you're working through problem and project-based learning. The algorithms concept comes into this as well, because we're going to be focusing on projects that have digital technologies at the core, and creating digital solutions requires some form of algorithmic work, both in the development stage. So when you're thinking about not specification so much, but the design phase, as well as implementation when you actually build a prototype or build some kind of actual digital solution to solve a problem. So planning algorithms using pseudocode is a really nice way to get a starting point on those kinds of things in the project, like when you're writing planning for a story that students are writing, or if you ask your students to create a video, writing a plan and a storyboard at the start of that is really important. And that's the same with using pseudocode and things with algorithms. And then implementation is the actual creation phase of that. So at primary school level, we're talking about using things like Scratch or MakeCode websites or other visual programming tools so that the students can actually create their designs. And then thinking about the generating and design phase or the sub-strand, you've got things like user interface and impact as an important one as well. It comes up in that technologies curriculum, talking about impact and the way that digital solution actually creates some kind of interaction with a community or the world, and what impact that has and how you can use that to continue solving problems. Looking at the actual sub-strands that relate specifically to project work in digital technologies, They're here. We're going to go through them in this order throughout the presentation, investigating and defining links to that concept of specification, generating and designing. Some of that will be covered when you've learned and taught about algorithms, and the algorithms presentation has some really good content on that. Producing and implementing is also another algorithm phase, where you're actually taking your algorithms that you designed and creating a digital product. It also can be linked really nicely to design and technologies phases as well, if you're actually creating something physical that is going to be an interface for the digital solution that you've created. Evaluating is a great point to look at impact and interactions and to make decisions about what next, and how can maybe I do some research to discover a better way of solving my problem. And then finally, collaborating and managing underpins all of this. It's a really big part of the digital literacy capability, and we will be touching on that a little bit as we go as well. And of course, any quality teaching program needs to start with looking at the achievement standard to find out what that endpoint looks like for your students. We've highlighted the important parts in red here of the achievement standard for years 3 and 4 and 5 and 6. And we'll touch on these as we go through as well when we start talking about assessment, that these are the really important things. But again, starting with looking at what you're going to assess is a really important way to move forward with your planning. As far as the rest of the curriculum goes, with the content descriptions and elaborations, we'll point to those as we move through each of the sub-strands.
So what we're going to be looking at across the rest of this presentation is one unit of work. It was actually done across an entire term, and it was cross-curricular. So the rich concept was based on the idea of sustainability. So when you're thinking about starting a project, you need to think, is this going to be a sequence of lessons over a few weeks, or is this going to be part of a bigger project that might take the whole term and involve multiple curriculum areas? To begin, we might start with something like sustainability and then move into picking or selecting picture books or novels that will tie into that theme. So here's 3 images that outline what we were doing. The user story that went with this was based on the future and moving to Mars. Mechanica, the picture book, which was one of the books that was selected, is a futuristic book, science fiction genre. So it was about climate change and how humans had ruined ecosystems. That's basically the theme of Mechanica. So due to climate change, human destruction of ecosystems, Earth has become almost uninhabitable for human life. And a group is being sent to Mars to create an advanced colony. And you've been asked to help design the habitat in which everyone will live. So this would be your hook that you would begin your unit with. And you might start by reading the book or looking at pictures or showing different ways that people live in different habitats. And you can see on the left, there was an element of design. Those little plastic stencils on the desk are called Splat 3D. There's a link in the resources to those. And they were used by the students to draw cubes and cylinders. So we're obviously doing some maths with that. Then they had to construct prototypes of their sustainable habitat. And it was done on a piece of cardboard from a fridge box. We lined it with 1 centimetre grid paper. Each child was given 25 centimetres to construct their habitat that was hopefully based on the design that they had built. We also talked about hydroponics. We talked about sustainable energy sources. We talked about how to minimise waste. Lots of different environmental themes in the context of being self-sustaining when we move to Mars. And on the right there, you've got a picture of a pressure switch. The reason I've included this is so that when we refer to a pressure switch, you'll know what it looks like and you can picture it. What happens is it's actually hooked up to a small device called a makey-makey. When they press it, it runs a doorbell. So this could be used as a button for a machine. It could be used as a doorbell. It could be used as an intruder detection in form of a pressure switch under a mat. If weight goes off the mat off the pressure switch, it might sound an alarm. So that was actually a design task as well. So when we're planning one of these units, where do you start? The first thing that I do when I'm planning a unit is think about how all the different curriculum areas link together and what can I do in those subjects that is relevant, that is achieving content and achievement standards, but is not going too far with believability or relevance. So art is absent from this because art was a different unit. It wasn't relevant to this subject that we chose, even though there was quite a lot of creativity. It wasn't a specific art lesson, so there's nothing. This would be how I would plan my unit. I would start with my topic in the middle and then go out to different curriculum areas and put concepts that might be taught across the term into those curriculum areas so that I can actually know where I'm actually hitting different content descriptions and achievement standards. Once again, English and maths, people often want to be very specific about their programming. So from a practicality point, I would have a document for English, a document for maths, and then I had another document for my integrated approach with other subject areas. For this presentation, we are purely focusing on the red boxes, which is the digital technologies. But as you can see, a lot of the science investigations are going to link to the microbits and the use of those in the investigations. We're just talking about digital technologies. So when you're designing your project, remember you don't have to assess every single task. You're looking at what you assess across the year and ultimately across the 2 years. You do need to consider what will be assessed when you're planning your unit. So hopefully when you're planning your unit, you're thinking about all of the learning experiences that you're going to develop, how it's going to consolidate the understanding in digital technologies. And at the same time, you want to ensure that they're authentic learning activities that are going to be engaging. We want to always consider the achievement standard. And some of the methods that we could use are questioning, observation, discussion, and journals for formative assessment. We'll talk more about assessment at the end, but we will touch on little bits of assessment as we go through each of the sub-strands in digital technologies. Very quickly, I want to refer back to the achievement standard. Here I've taken the red sentences that we had highlighted in the achievement standard, and I've taken out the sentences and put them into very basic statements. And that makes it much easier to understand what I have to do in my unit when I'm planning it. So you always pay attention to the verbs that we've got and what you have to assess. I think sometimes we over-assess and we make things too complex for our year level. So be sure this is the year 3-4 and then the year 5-6, slightly different. Make sure you focus on what the verbs tell you that you need to assess, and you should be right if you start that at the very beginning of your unit. This is a little bit of humor, but actually reality. We go into a project thinking the image on the left will be the process, and what actually happens is what's on the right. You get to a point in the project, you don't know how to do it, you don't know how to fix it. We have to go back, it didn't work, we have to change that. Remember, you're not the only person. You're the only person in the classroom, but remember, you can call on expertise in your school community and your class community, parents. I've had builders come in, architects come in and help and run little sessions. You do need to be selective to make sure they've got the people skills that you want. But once you get to know some people in your school community, they're very, very helpful and very useful. And other ways, scientists in schools and digital technologies in schools with STEM specialists through CSIRO. If you contact them, we'll put the link in the resources. They can often provide a specialist to help. Or you could use social media and reach out to companies and individuals on social media who might be able to Zoom with you. You could Zoom with professionals, a vet, or contact a zoo. There's always somebody who might be interested to talk to you about different concepts you're teaching.
I really love that analogy there with the sort of flow diagrams, Meredith. I always found that projects do go backwards and forwards and become a bit chaotic, and it's one of those things that can be hard to let go a little bit of control of the way things are progressing. If you always think of your projects as linear, you probably end up telling the students what to do the whole time to control that. Whereas if the students really need to get in and design their own ideas, it's almost impossible to avoid that little element of chaos and with things going in directions that you didn't expect. But I think often those directions are the ones that kids remember, or kids really generate some amazing learning. So my advice in this, when you're thinking about running a big project, an integrated project with this problem solving, concept behind it, is don't be afraid to lose control.
And I think the other thing is, Dion, is planning. If you're organized and you have everything you need, it's much, much easier to run a project on that right-hand side. Like you said, the one on the left is very teacher-led, and you only have the materials for the lesson you're up to. Whereas if you have all the resources ready in a box or in the storeroom or in the back of the classroom, and you've got experts planned, or you, in the back of your mind, you know you're going to need an expert, where are you going to get one? Talk to friends, talk to people, to other teachers. Do they know any parents? Parents are going to be your biggest help. And I mean, schools often have quite a range of professionals to access, especially now that we have remote working. Small towns now have more access to people because they work remotely, or they fly in, fly out, or you can just contact someone. I contacted a games developer on social media, and she Zoomed with us, and the kids loved it. So it's really important to remember you're not alone and that you can contact others. But being organized, number one, have everything ready, and experts.
So let's now take a look at the first of the sub-strands that deals with the project ideas and project management ideas for students. Having a look at investigating and defining, there's the sequence of content descriptions across the year levels. Again, it's always worth looking before and after where you're teaching. We're going to talk about the year 3 to 4 and 5 to 6 descriptions as we go. This project example that we're using could quite easily fit within either of those year levels because the content descriptions are very similar. There are just some more advanced ideas and more complex concepts that you deal with when working with year 5 and 6 students. But the key thing we're looking at here is defining problems, and a couple of ideas with some new terms in there, given design criteria, and with years 3 and 4, co-creating user stories. So we will talk about design criteria and user stories as we move through this section. Again, just a key focus here, thinking back to our achievement standard, what is it that's in this content description that we need to assess? So with year 3 and 4, the user stories part is not actually something that's in the achievement standard, so it's not something that has to be assessed. But the idea of looking at design criteria that's been given and deciding whether those have been met is definitely part of what needs to happen here. And for year 5 and 6, so they will be needing to know and be assessed on their use of user stories. The idea that they're co-developing design criteria, that's not something that's necessarily in the achievement standard and not on the assessment card. So let's look at terminology. This new idea of user stories in year 3 and 4. You'd be giving this to students, and they can work with you or with others to create user stories. Now, a user story is a description of, in a digital technologies concept, key features of software or a digital solution that the end users require. So this often looks at why the user wants this particular feature or a particular solution to do what it is that they need to do, and they become part of this iterative design process. Usually, a good way to frame them is in this: as some particular type of user, I need a particular goal, so that I can achieve this particular thing. So a couple of examples there. As a teacher, I need access to the curriculum scope and sequence so that I can plan appropriate lessons for my students' stage of development. That's a pretty bland one. But what about another user story for a teacher? As a teacher, I need access to large amounts of coffee without leaving my classroom so that I can remain sane throughout the day whilst not leaving the children to create chaos. I'm sure many of you coffee lovers can understand the relevance of that. But it's a user story that would allow someone to come up with a design and implement some kind of solution for you that would help you to get your large amounts of coffee without leaving your classroom. Let's think about now the Mars project that we were talking about, where we're designing a new colony on Mars and thinking about a digital solution that may be something that's useful in this new colony. So again, that sample scaffold there, as a user, I need some particular goal so that whatever reason I have. A couple of examples: a doctor in the new colony may need to may be given the job of measuring air quality and making decisions about how to support the health of the people. So the doctor might need to know that the air quality is good so that they don't have to treat people's asthma, or know that the air quality is poor so that they can enact some kind of change to improve that. Maybe there's a particular type of scientist whose job is to work within the climate inside this colony. And we may be imagining the colony is in some kind of bubble or dome that's controlled, and they might need to know how windy it is outside so that they can be sure to make the colony safe. Or an engineer of some kind needs to make sure that people aren't using too much electricity so the colony can be sustainable. Again, those are some examples of user stories that help a designer to come up with a solution that is going to meet the needs of that particular user. The other element of this that we talked about is design criteria. A really simple definition here is design criteria is used to determine if the proposed solution meets the requirements. They come from, and there are three elements here: solutions requirements, user stories, and the constraints, which are the things that limit how you can create your particular solution. So we'll go through a little bit of an example here. So design criteria often fit within a design and technologies realm. So these examples on here, there are some solution requirements and some constraints that relate specifically to design and technologies, not to digital technologies. If we look at some design criteria for digital technologies, there's a whole variety of different possible things. A solution requirement may be monitoring the level of light, monitoring temperature levels, sound levels, the use of a pressure switch. Anything that can be controlled or monitored digitally could then fit within some kind of solution requirement. And again, if you're using year 3 and 4 students, you'd be providing those to them and allowing them. That helps with that sort of scaffolding their ideas and their design. Whereas year 5 and 6 students would need to be coming up with their own. So you might start with a user story, and then they can develop some design criteria, either with another, within a small group, or co-develop could also mean that they're working within some bounds that the teacher has provided for them as well. And think about constraints: low cost, must use a particular device. And again, we're going to talk a lot about microbits and things like makey, which are resources that fantastic for digital technologies, and we can't really praise these kind of devices enough, because they are a cheap and easily accessible way for students to access these kinds of solutions where they're making a physical solution that has a digital technologies component. And here's just a simple example of integrating those three ideas. Remember, we're talking about solution requirements, user stories, and constraints. So within one example, so a user story may be the doctor one we referred to. As a doctor in the new colony, I need to know the air quality is good so that people can breathe healthy air. Solution requirements, as an example, air quality must be continually measured, maybe every 30 minutes or something like that. The doctor must receive a warning before the air quality is too low for safe breathing. and the doctor must be able to release poor quality air from the habitat as a solution. So if the problem occurs, what can the doctor do and control that digitally by logging in and saying, open the vents, and something happens that opens vents to release some of this bad air. And constraints, all data and controls must be accessible to the doctor in the colony's health centre.
The next substrand is generating and designing. And we're just quickly going to look at the content descriptions that link to this substrand. There are two coloured boxes. The blue is the digital technologies content descriptions, and they start with the word design. That is a good sign that you're in the right substrand. The grey boxes start with the word generate. They're the ones we're going to address first. We're going to be talking about how we work with those for the next stage of our Mars project. A good place to get ideas if you don't know how to teach something is, of course, to go to the elaborations. If you don't like the elaborations, if they're not relevant to your topic area, you can actually take those first verbs in each of the elaborations and use those as a springboard into an activity which is relevant to your theme or your activity. Brainstorming, discussing, and ideating are your Year 3 elaborations. You can tell they're elaboration verbs because they end in ing. The Year 5 and 6 ones are looking at designing, ideating, and suggesting modifications. It's important to always look to the elaborations for your ideas, but they're not mandatory. But take those verbs and think, how could I brainstorm possible design ideas and discuss with my peers, instead of a computer game, my habitat. How could I do that for my Mars habitat? Discussing whether the needs are identified from the user story, whether they meet the design ideas, to encourage people to recycle. We're not doing recycling necessarily, so what we'll do is we take that concept and we place it into our classroom ideas and lessons. So back to the Mars sustainable habitat. The first thing we've got is a user story. Now for Year 3 and 4, this could be co-developed, or Year 5 and 6, they might be writing it on their own. It depends. It's a new concept, so you may still be co-writing. How I would do it is present them with a user story for the big project, then write one together, do some co-writing, and then in groups, encourage them to write their own specific to their activity. The first activity is for creating a light and a temperature sensors to monitor the light levels and temperature levels inside the habitat. Year 5 and 6 might expand that and monitor outside as well and have 2 microbits that can talk to each other and transmit information between the two. It's important that when doing coding that the students can write or say what their project's going to be about in plain words. So they need to be able to say, when a user presses button A, it will display the temperature in degrees Celsius for 2 seconds and then clear the screen. When they press button B, it will display the light level in lux for 2 seconds and then clear the screen. It's very important that they can say it in plain words so that then they can transfer that information into a flowchart. And these are 2 very important elements of design leading into coding. You want to really discourage kids from just turning on Scratch or turning on their MakeCode and starting to build blocks together. Even experienced programmers plan. So what I've done here is made a flowchart. The blocks are in the same color as the blocks you would expect to use in MakeCode, which is the microbit platform. My trick to you is to grab a box of whiteboard markers that has every color. And I used to write on the board in a box in the correct color of that matched the platform. And that way students are more self-directed. Once you've planned it, the hesitant learners are able to find the blocks and the menus quicker, particularly in Year 3 and 4. So that's what the purpose of the colors are. On button A press, show a number. What number are they showing? Temperature, which is an inbuilt function in the microbit. pause for 2 seconds, and then clear the screen. It's actually not hard code. It's definitely a year 3, 4 level code. There's no repeats, there's no variables, other than the inbuilt function that you can find on the pink menu. So the next substrand is producing and implementing. So we have got our content descriptions. There's actually no content descriptions specifically targeting producing and implementing. But what we do have are the algorithm content descriptors, which we've talked about in a previous webinar. While producing and implementing isn't specifically addressing the algorithms, you will be using algorithms to produce your digital technology solution, which is why we've put them here. Once again, you're going to look at the elaborations. You're going to be writing and editing programs, essentially. 5, 6 are going to be modifying programs, and they might be using year 5, 6 might be moving on to using simple circuits, where they might have sensors, they might have servos, which are little motors, and they'll be incorporating those into their little projects.
I might just throw in here at the moment too, Meredith, looking at this this particular substrand, you'll notice that all of the substrands through digital technologies have this combined two verbs in here, producing and implementing, or generating and designing. And in most of the cases, one of those verbs is in the content descriptions for digital technologies, and the other verb is actually used in the design and technologies subjects. So we'll notice here we're talking about producing and implementing, but the verb that applies here is implement. You would find in the design and technologies content descriptions for this substrand, they would have producing as the verb. And it works that way throughout most of these substrands in the digital technologies, that one of the verbs is the key one. We did find in the previous one that both of those verbs appear. So we have generate, or you can see it here. You've got generate and design at year 5 and 6, but not in year 3 to 4. And it's actually, even though it's generating designs, the verb is actually generate at this level. So that's just one way to think about the way that these combined substrand names work, is that they're for digital technologies and design and technologies, and that often we're crossing between the two.
We have already designed our code. We've already planned our project. Now it's up to producing. So we're going to look at how we implement our designs and our planning into an actual algorithm that we can use with our digital tool. This is the code that you would use for a microbit. And this is actually the one program, and we're using 3 different triggers: on button A, on button B, and on A and B when they're pressed. It will show the number for the different functions, temperature, light, and sound. It will pause for 2 seconds, which is 2000 milliseconds, and then clear the screen. I don't know if you recall the flowchart that we used, but this is actually exactly the same that we had in the flowchart. And this is the code for the pressure switch. This is the code you would use if you've got the pressure switch under your mat, you want it to wait 5 seconds, stop all sounds, and then play some sort of alarm that would indicate you have a delivery sitting on your doormat, or you might have your home takeaway might be sitting on your doormat, and this would be what triggers after 5 seconds. So if the cat walks across the mat, it's not going to sound. Currently, there is no way to turn it off until you lift the delivery off the mat. Once you take the pressure off the pressure switch, it will stop, because it only operates when spacebar is pressed. If you want to turn it off inside and override that, you're going to have to come up with some more code. What if we wanted an intruder detection system? This would be more of a 5-6 project. You can see that it's got if then else statements in it. It's also got some references to using the right arrow. It's got backdrops, there's sounds. It's also got a forever loop. This is definitely moving into the 5-6 zone of coding. How this will work is the code operates when the circuit is broken. So we have the pressure switch on. Somebody breaks the door seal or opens a window, it will sound. So you would have a piece of wire or two metal contacts that one on each side, and they're touching, and when the door opens, that's when the alarm would sound. So this is a little bit more complex use of the idea of having switches or circuits, but it's definitely 5/6 space.
In that kind of algorithm, it's hard within Scratch to actually simulate, for example, a door or a window being opened. So that's the right arrow key being pressed is just a way of demonstrating within a prototype that this is how it would work, that right arrow key input would be created by an input coming from some other device that's actually telling you, wait, this door's been opened. So if you don't have physical devices to do this, you can still create these simulated versions in Scratch, and your students would just need to be able to explain what that means. So when right arrow key is pressed, that's that's an input signal that's being sent from a window being broken or something like that.
Now, I think back to the user stories, and we had a design criteria for a doctor with air quality. So this is once again a 5/6 concept where we've got a sensor attached to the microbit. So on start, we've got a sensor attached to pin 0. And then what will happen is when the air quality goes above a certain level, you will have a sad face. If the air quality drops below a certain level and it gets back to a healthy level, because ideally you would want less particles in the air for a healthy air and a healthy atmosphere, you would see the love heart show, which indicates that the air quality is now back to an acceptable level. So with this project, you would actually need to have purchased the sensors that you need. Once again, it's including circuits, you'll need batteries, and it also has some variables there. Current air quality, previous air quality are variables. It's got a repeat loop, it's got an if statement, so you've got some branching, some iteration. So it's a really good project. Not too difficult for 5/6. What you do is you break it down into small steps and build it up slowly.
So the next substrand is the evaluating substrand, and it's forming a nice part of this process that we're going through, where we've defined our problem, we've come up with what the problem means, we've made a design on how to implement our solution, we've started to build that solution, and now we're at the point where we need to start assessing whether our solution's actually working and meeting the needs of the design criteria and the user stories. So again, having a look at the content descriptions for year 3 and 4, discuss is the key verb here. So thinking about how existing and student solutions have satisfied design criteria and user stories. These would be looking at a particular circumstance that's existed and actually nutting through whether the students think that the design criteria and user stories that were given to them have been met. And with year 5 and 6, they actually need to look at existing systems as well and student solutions and looking at whether they meet design criteria and user stories. And now there's this extra part on the end here that says, and their broader community impact. And we've talked about impact when we were looking at the technology learning area concepts right back at the start. Impact is thinking about how this affects the community, people, the world, and what does that mean for my solution that I've created. So I'll touch on that again shortly as an example of how we can look at one of our examples that we've given in this project and how the impact that that particular type of solution has in a real world context at the moment. And again, looking at our content descriptions broken down into elaborations with plenty of options for thinking about how can I do this. And again, as Meredith mentioned before, if your project doesn't link to the elaborations that are in here, think about those verbs at the start because they can really help to guide you in the kinds of things that you're getting your students to do. So for year 3 and 4, describing, discussing, making judgments and reflecting. And reflecting is the real, for me, the real key in this evaluation section. It's about thinking about my solution or someone else's solution and does it work? Does it do what it was intended to do? And not at a technical level, not is the code good enough, but more looking at that whole part of the process. Have I done the right thing? Where to next? If I may be meeting the needs of the design criteria, how can I do that in a better way? Evaluation is all about these different ideas here. We've talked about design criteria, but we're now analyzing, and these are higher order skills than we've used so far. Everything up until this point has just been coming up with ideas, trying things out, creating something, but now we're actually going to use those higher order thinking skills and start analyzing what is it that we're doing, and have we truly met those needs. And again, looking at impact. So it's a really great way, and impact is probably one of the really big concepts within technology that relates to the world. So how well does it address the problem? Is the impact my solution has positive or negative? Perhaps my solution may actually meet the needs of the design criteria, but it may have some other like negative impacts on other people or the world. If every time I get something put on my front doorstep, an alarm goes off in my house, is that going to bother people? Is the alarm that loud that my neighbours can hear it? Does the dog across the road or someone's pet get triggered by these noises? There's a whole variety of things that you can think about, and they'll come from that interactions and impact concept of the technology's learning area. And again, really focusing on the design criteria, you can see how important that is. If we have to evaluate against design criteria, but we didn't create them at the start, or they weren't given, or we didn't focus enough on that, it's going to be really hard to assess students in this area and for them to actually show an understanding of this particular substrand and these content descriptions, because you haven't focused on that. So the planning, those early stages really show up as being really important. And just some techniques for doing this in the classroom. So we want to encapsulate the way students are thinking about these and evaluating their own projects. In the chaotic world of a project-based classroom, you'll be talking to kids a lot, and that's one way to do it. But sometimes you can't capture that information very easily, so you need some methods for doing that. So yes, discussions are great between teacher and students, or students and students, small group reflections, and actually giving leading questions to the students to say, in your group or on paper, you could do it individually, write down some answers to these reflection questions. Having a journal throughout the project is a brilliant way to capture their learning and their understanding of all of these ideas. The goal of a project like this is not to assess a student's final product. It's actually to assess all of these points that we've been touching on as we go through. And that's the really key element of the curriculum, and the digital technologies curriculum being part of the technology subject area is heavily focused on this throughout all of these substrands.
So the final substrand for digital technologies is collaborating and managing. We have one lot of content descriptions pictured here. There is another set, but these are the ones that are relevant to collaborating and managing. We're looking at breaking down these content descriptions into two parts. The first part is select and use appropriate digital tools. And then the second part is what you're going to be using those tools for. It also then moves slightly into the privacy and security component, where they're talking about being supported by trusted adults and using agreed protocols and agreed behaviors. So really the focus is using your digital tools, which is digital literacy. The next slide includes both of those content descriptions that you would see in your curriculum document. We're looking at the second row, which is where we're going to share content, plan tasks, and collaborate. So if you have a look, it includes simple things such as using an agreed folder for sharing the documents and being able to locate those documents. With years 3 and 4, they're going to set up a set of steps that they have to follow to find information online. So they're doing Google searches and using search engines. And then they might also be using different ways to communicate their information. It's important that you actually teach these tasks, because this is the digital skills that students need to be able to communicate and work effectively online. The Year 5, 6 one that we're talking about is this, once again, the second row, and it's where they share content, plan tasks, and collaborate. You can see here we've broken down those content descriptions into the two types of skills that they will need. One is the soft skills, the respect, the being able to collaborate, creating a plan and sticking to it, working to a time limit. Those sorts of things are about managing your project. For collaborating, you're also going to need your digital tools. You need to be able to work on your LMS of choice. That might be Google Classroom, it might be SharePoint. You need also to be able to share documents. You don't want your students saying, he changed my writing, I don't want it read. Or she's deleted my work, I didn't want it deleted. Those are the types of skills that we're talking about here. Being able to collaborate in an online environment and not upset other people's work and come to an agreement before making changes.
One of the other differences between the Year 3 and 4 content description and the Year 5, 6 content description is that Year 5 and 6 have that option where it says select in their choices. So they're looking at select and use appropriate digital tools, whereas in Year 3 and 4 it just says use the tools. So looking at that progression, it's about in Year 3 and 4 you produce the tool for them, whereas in Year 5 and 6 you might say to them, you need to create an online presentation, or you need to show your learning digitally, and then the students can select the tool that they think is most appropriate. And obviously, if they select an inappropriate tool, then you need to have some more discussion around what makes a tool suitable for a particular need. So now that we've taken a look at all of the substrands, let's just have a discussion about assessment and the different ways that you can consider deciding if your students have met that achievement standard. The achievement standard is the place to go so that we know what it is that we need to be assessing. We looked at that at the start of our unit in our planning, so we were aware of that through the whole way through. And at key points along the way, we've also captured some evidence of that achievement from our students so that we can assess them on their learning and report back on their achievement as well. There need to be multiple opportunities to be assessed and to demonstrate success, and then using different types of assessment where possible. So formative or summative assessment. So the idea of assessing for learning that helps you to inform your teaching, assessment as learning, another form of formative assessment, and then assessment of learning, some kind of summative ideas. And the summative ones are really good towards the end of projects, not again to assess their solution and what they created, but to assess their understanding of this process and of all of these parts to the achievement standard that we've covered along the way. Some ways of doing that, some formative methods, asking questions, making observations of what students are doing, collecting work samples, photos and videos, classroom discussions. They're all very useful things for you as the teacher to be able to see what the students understand so that you know where to go next. And then the summative things, maybe some kind of formal assessment task where they do a presentation, or they might have to just demonstrate their learning in some way, the evidence of the actual solution that they created with some kind of reflection on that, photos, videos, again, observations and work samples, or even giving them a test on some kind of element of what it is that you wanted to understand. And looking at Year 3 and 4, what might those things look like again? We're creating simple digital solutions. How can I assess that? I need to be able to see those solutions and check that they have met the design criteria, which looks at the next one. So using the provided design criteria, again, we're not assessing Year 3 and 4 students' ability to make or create design criteria, but they do need to be able to use them and create solutions that meet those needs. And then the third one here, use the core features of common digital tools. That's the digital literacy content of this particular type of work. So assessing whether students are actually using the technology that they have to meet all of the needs of this project process that we've been working on. And just another example here of a task that you might assign to Year 3 and 4 students based on again, a hypothetical situation where you're pushing this out to them towards the end of this project. So the electronics company provided you with a control panel for your new sustainable home to control the door alarm, temperature, and light levels, looking back to some of those user stories and algorithms that we investigated before. And you might provide students with a picture of a user interface and the design criteria that were given as part of this scope. And then the students may look at this and assess whether that particular interface meets the needs of those given criteria. So they may be asked to include what are good features of it, what are negative features, what worked well, what is missing, and that will allow you to take a snapshot at the end as a summative task of what the students have learned and whether or not they have met the achievement standard for this particular year level.
Year 5 and 6, similar but a little bit more complex. They have to develop and modify digital solutions. They have to define problems and evaluate solutions using user stories and design criteria. Remembering that in the content description, it said co-develop design criteria, but you're not assessing that. Once again, they just have to be able to use it to evaluate what they can see or what they've made. This is our suggested user story for finishing off our sustainable habitat. On the right there, I've got a sample of what you might expect a year 5-6 student to be able to make. This was actually just done in PowerPoint with a combination of rectangles and some text. It's just digital literacy, once again. So after the living in the habitat for a while, you've decided that you would like to have an interactive panel that allows you to check the temperature, light levels, and stop the sounds of the pressure switch. This is very similar to the previous story, the difference being year 3-4 were given the panel, year 5-6 are expected to design their own panel. And once they've generated and designed the user interface using paper, they then would move on to an online presentation tool such as PowerPoint, or they might like to make it in Scratch. Now, once again, that's actually going to be a far more complicated project because that actually will require designing and planning and prototyping, So this is a very simple assessment task. What do they understand about design? What do they understand about the needs of their habitat? So they're having to process and evaluate what they've done to then incorporate into this panel. This has been used in previous webinars, but I've modified it again as a feedback mechanism. The students write about what they've learnt. They evaluate. So this could be done with years 3-6. Year 3-4 might have a little bit more structure. You might put vocabulary on the board. You might write questions up on the board for them. You might discuss questions. Then the students write it up. Once again, down the bottom, we've got a strip of statements directly linked to the achievement standards. The students can self-evaluate how they felt about this project or each of those statements, and the teacher can then assess beginning, grade level, and achieved. The reason I would do these is to put them in portfolios to send home. If you wanted, you could condense that writing to one page and then have a blank page for a photo or a drawing. You might take photos of their projects or their designs, and then I would print them out on a piece of paper and the students cut them out and stick them on the page. Remember, if you're sending it home in a portfolio, you need to record the results so that you've got it for when you do reporting. Lastly, we've got some project ideas for you. So these project ideas are totally unrelated to the project we've just gone through. That previous project, that was a full terms integrated unit across all curriculum areas. And what we want to illustrate was you don't have to do that. You can just choose a smaller project on a smaller scale that might take 4 lessons or 5 lessons. And you can choose to fit in with a theme that you're doing. My absolute favorite, design and develop your own AR experience. And you can use these to document learning, document models, so the students can take photos, record video of themselves, they can take photos of artwork, and you could actually document an entire terms experience if you wanted to with students just documenting their work along the way. The best thing about this AR experience is it is a free tool, and they have to plan it just like they would plan an app. It's not difficult, but it does require you as the teacher to go in and understand how it's structured and how it works. Then you've got a practical task. Create blinkers for a student in a wheelchair with actual buttons that work. So if you're doing circuits in science, this might be a practical task that the students could then work through based on somebody's actual needs. Design and develop a money counter in Scratch using an interface that is either digital or physical. So money is actually conductive. So you could make yourself a little money counter using a Makey and Scratch. Or if you don't have Makey, you could do it just in Scratch, and they could have a digital interface with a picture of the coins as the sprites, and the students click on each of the coins and it adds it up for them. The coding in that, if a Year 4 class has been doing a lot of coding, they would be able to do this. There's a lot of joins. It might be a beginning Year 5 project where students are taught actually how to use joins and how to do the multiplication. There's a lot of calculations. Design and develop a times table generator with a physical interface. Once again, this uses, it's a little bit of a chatbot style where the students get prompted to enter some numbers and then they have to type in the answer to the multiplication. You could design a physical interface or have a virtual interface, a digital interface on Scratch, once again. And then finally, design and develop an online game using Scratch. And the sample games link actually takes you to Code Club AU, which is pictured on the right of the slide there. And I would probably play a couple of games or build a couple of the games that are inbuilt in Code Club first, because they teach you all the concepts. So if you wanted to have a counter, they might need to go and construct the game that has the counter. And maybe for Year 5, 6, they could just modify the game, bring in some new sprites, use the same code and change the purpose of the game, but they would have a counter. So there's timers, there's all sorts of different functionalities on all the different games. If you're going to teach with Code Club, once again, I would recommend you print out the project sheet and run through it yourself. Always do your coding first. You read the novel before you teach the novel in English. So in digital technologies, you do the project yourself. Any problems that you have, multiply that by 5. That's what's going to be the problem in the class. So if you've done it first, you've worked out the solution, you know where you're going. Start in your space where you love and bring some technology into that space.
So just to recap on these ideas, investigating and defining a problem. So don't forget, a good project always starts with having to solve something. Then once they've defined that problem, they're going to be generating ideas and designing some kind of solution. Once their solution is ready to move to the next phase, they'll look at implementing some kind of digital algorithm that creates the solution that they've looked at. And then once they've moved through that phase and have created some kind of prototype of their solution, they're going to start evaluating that and deciding where to next and how to improve on that, all the while looking at these collaborating and managing digital literacies type skills as they move through, and then you'll be assessing them at the end. Finally, we'll just move on. There's a whole heap of other resources through here that you can click through when you're looking for ideas, and some other skill building for yourself as a teacher. If you want to know how to do some certain things, you can go to a lot of these websites, find out how to do stuff. That really brings us to the end of this particular presentation and brings us to the end of the whole series of version 9 Australian curriculum updates for digital technologies. And you can scan the QR code to find us or hit us up at help@grokacademy.org. But thank you from me, Dion, for persisting with our presentation. And Meredith?
Thank you. Thank you. It's been great working with these 7 series webinars. I hope you enjoyed them.